According to the National Electrical Code, the subpanel should have been a main lug-only panel. The main breaker in the subpanel at 200 amps exceeds the ampacity of the feeder cable. The 4/0 aluminum SCR cable is rated for 125 amps. The feeder cable should be sized to match the ampacity of the subpanel main breaker, as per National Electrical Code 240.24b. Since the feeder cable is not rated for 200 amps, it cannot safely supply the full load that the subpanel main breaker would allow. National Electrical Code 240.24b states that conductors supplying one-phase load shall have an ampacity not less than the current rating of the main circuit breaker or other overcurrent protective device, either a fuse or circuit breaker that it supplies. Therefore, the subpanel should have been a main lug-only panel to comply with the National Electrical Code. Let's delve deeper into the reasons behind this requirement and understand the electrical principles at play. The National Electrical Code is a comprehensive set of standards designed to ensure the safe installation and operation of electrical systems. Its primary goal is to protect people and property from electrical hazards such as fires and electric shock. The code is updated regularly to reflect the latest technological advancements and safety practices. When an electrician installs a subpanel, they must adhere to the National Electrical Code guidelines to guarantee the system's safety and reliability. A subpanel is a secondary distribution point for electrical power, typically located away from the main service panel. It receives power from the main panel through a feeder cable and then distributes it to individual branch circuits within a specific area of a building. Subpanels are commonly used to supply power to additions, workshops, or other areas that require a dedicated electrical supply. There are two main types of subpanels: firstly, main breaker panels, and secondly, main lug-only panels. A main breaker panel has a built-in main circuit breaker that serves as the primary disconnect for the entire subpanel. This breaker provides overcurrent protection for the subpanel and allows for easy shutoff of power to the entire panel. A main lug-only panel, or a MLO panel, does not have a main breaker. Instead, it has lugs that are connected directly to the feeder cable from the main panel. The overcurrent protection for an MLO panel is provided by the breaker in the main panel that feeds the subpanel. The ampacity of a cable is its current carrying capacity, measured in amps. It is the maximum amount of current that a cable can safely conduct without overheating and potentially causing a fire or damaging the insulation. The ampacity of a cable is determined by several factors, including firstly, the size of the conductor, secondly, the type of insulation, thirdly, the ambient temperature, and fourthly, the insulation method. The National Electrical Code provides tables that list the ampacities of various types of cables under different conditions. For example, a 4/0 aluminum SCR cable, which stands for Service Entrance Cable, is commonly used for feeder circuits in residential applications. According to the National Electrical Code, a 4/0 aluminum SCR cable is typically rated for 125 amps under normal conditions. This means that it can safely carry up to 125 amps of current. When selecting a feeder cable for a subpanel, it is crucial to choose a cable with an ampacity that is sufficient to handle the expected load. The load is the amount of current that the subpanel will be required to supply to the branch circuits connected to it. The National Electrical Code requires that the feeder cable be sized to carry at least 125% of the continuous load, plus 100% of the non-continuous load. This ensures that the cable will not be overloaded under normal operating conditions. In the situation described, a 200 amp main breaker subpanel is being fed with a 4/0 aluminum SCR cable from a 125 amp breaker located in the 225 amp main panel. This configuration violates the National Electrical Code because the ampacity of the feeder cable, which is 125 amps, is less than the rating of the main breaker in the subpanel, which is 200 amps. National Electrical Code 240.24b specifically addresses this situation. It states that conductors supplying one-phase load shall have an ampacity not less than the current rating of the main circuit breaker or other overcurrent protective device, whether it is a fuse or circuit breaker that it supplies. This means that the feeder cable must be sized to match the rating of the subpanel's main breaker. In this case, the 4/0 aluminum SER cable would need to be replaced with a larger cable that is rated for at least 200 amps to comply with the National Electrical Code. Alternatively, the subpanel could be replaced with a main lug-only panel. With a main lug-only panel, the overcurrent protection is provided by the 125 amp breaker in the main panel that feeds the subpanel. This breaker will protect the feeder cable from overload in short circuits. By using a main lug-only panel, the electrician can avoid the need to upgrade the feeder cable. The reason the National Electrical Code requires the feeder cable to be sized to match the subpanel's main breaker is to prevent overcurrent situations. Overcurrent occurs when the current flowing through a conductor exceeds its ampacity. This can happen for a variety of reasons, including firstly, short circuits, secondly, ground faults, and thirdly, overloaded circuits. When a conductor is subjected to overcurrent, it will overheat. This overheating can damage the insulation of the conductor, leading to insulation breakdown and potentially causing a fire. The main breaker in a subpanel is designed to protect the subpanel and its branch circuits from overcurrent. If the main breaker is rated higher than the ampacity of the feeder cable, it could allow the feeder cable to be subjected to overcurrent without tripping. This could create a dangerous situation where the feeder cable overheats and causes a fire. By requiring the feeder cable to be sized to match the main breaker, the National Electrical Code ensures that the feeder cable will be adequately protected from overcurrent. If an overcurrent situation occurs, the main breaker will trip, cutting off power to the subpanel and preventing the feeder cable from overheating. In addition to National Electrical Code 240.24 Bohm, there are other National Electrical Code articles that are relevant to this situation. National Electrical Code 310.15 addresses the ampacity of conductors and provides tables for determining the ampacity of different types of cables. National Electrical Code 250 provides requirements for grounding and bonding electrical systems. Proper grounding and bonding are essential for preventing electric shock and ensuring the safe operation of electrical equipment. National Electrical Code 408 covers switchboards and panel boards, including subpanels. It provides requirements for the installation, wiring, and overcurrent protection of these devices. In summary, when installing a subpanel, it is crucial to comply with all applicable National Electrical Code requirements. The feeder cable must be sized to match the rating of the subpanel's main breaker as per National Electrical Code 240.24 Bohm. If the feeder cable is not rated for the same ampacity as the main breaker, the subpanel should be a main lug-only panel. Following these guidelines will ensure the safe and reliable operation of the electrical system. It is also very important to select the right size of conduit. Conduit protects the wires, and the correct size of conduit ensures that the wires do not overheat. When dealing with electrical installations, it is also important to understand the concepts of voltage drop, resistance, and impedance. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and can also lead to overheating of conductors. Resistance is the opposition to the flow of current in a conductor. It is measured in ohms. The resistance of a conductor depends on its material, length, and cross-sectional area. Impedance is the total opposition to the flow of current in an alternating current circuit. It includes both resistance and reactance. Reactance is the opposition to the flow of current due to capacitance or inductance. Understanding these concepts is essential for designing and installing safe and efficient electrical systems. When working with electricity, it is always best to consult with a qualified electrician. Electricians have the knowledge and experience to ensure that electrical installations are done safely and in compliance with the National Electrical Code. Working with electricity can be dangerous, and it is not worth risking your safety or the safety of others by attempting to do electrical work without the proper training and experience. Remember, safety is always the top priority when working with electricity. Always turn off the power before working on any electrical circuits. Use the proper tools and equipment. Wear appropriate personal protective equipment such as safety glasses and rubber gloves. And never work alone. Having someone else present can be a lifesaver in case of an emergency. The information provided here is for general educational purposes only and should not be considered as professional electrical advice. Always consult with a qualified electrician for any electrical work or installations. Ignoring electrical codes and safety practices can lead to serious consequences, including fires, injuries, and even death. By following the National Electrical Code and working with qualified professionals, we can ensure the safety and reliability of electrical systems in our homes and businesses. The correct installation of a subpanel involves careful planning and attention to detail. It is not simply a matter of connecting wires. It requires a thorough understanding of electrical principles, safety practices, and code requirements. A qualified electrician will take the time to assess the load requirements, select the appropriate components, and install the subpanel in a manner that is both safe and compliant with the National Electrical Code. This includes ensuring that the feeder cable is properly sized, that the overcurrent protection is adequate, that the grounding and bonding are correct, and that all connections are tight and secure. In addition to the technical aspects of the installation, a qualified electrician will also be able to provide guidance on energy efficiency and other related issues. They can help you choose energy-efficient appliances and lighting fixtures, and they can advise you on how to reduce your energy consumption and save money on your electricity bill. Choosing the right electrician is an important decision. You should look for an electrician who is licensed, insured, and experienced. Ask for references and check online reviews. A reputable electrician will be happy to provide you with proof of their qualifications and will be willing to answer any questions you may have. In conclusion, the installation of a subpanel is a complex task that should be performed by a qualified electrician. The National Electrical Code requires that the feeder cable be sized to match the rating of the subpanel's main breaker, as per National Electrical Code 240.24 bone. If the feeder cable is not rated for the same ampacity as the main breaker, the subpanel should be a main lug-only panel. Following these guidelines will ensure the safe and reliable operation of the electrical system.